What's poppin', dogs? It's Mr. Allen with a video on regression models in your TI-84 Plus graphing calculator. We've got historical data on the performance of the S&P 500. It's been provided right here in this wonderful table. All right, determine whether a linear or exponential regression model would better fit the data. Then we're going to use that model to predict the price in 2034, so another 10 years out. So I actually did pull this data from the internet. It's the real deal. Okay, these are the real numbers. So if you pull up the Google machine, search S&P 500, like I have right now, it pops up the day right here. Well, you can go out to 6 months. You can go out to a year, your year to date, 5 years. I went to max, and now you can really see this curvature to this graph. It very much looks kind of like exponential growth, but we'll find out which model it fits better, okay? So if you come all the way to the end here, we had February 17th, 1984 was 155 and 74 cents. So I figured about 156, right? And then I came over to 1994. I tried to get February again, somewhere in here. You know, we get to the 466 was a pretty close one. And then to 2004, pop over here, you know, and see what we got in February 2004. Almost there. There we go. Boom, 1142, so on and so forth. So I just went like each decade. And as you can see, I mean, there's times where it's like way higher up and then it dips down, comes up, comes down. But on average, what's it going to do? Okay, and that's what we're going to figure out right now. So yeah, I only have 5 data points. You probably want a few more to make a more reliable model, but just so it's not overbearing on typing all this stuff in, we're going to stick with these 5, okay? Now, when I type this into my calculator, rather than using the 1984, 1994, so on and so forth, I'm just going to go with, how about 0, 10, 20, 30, 40. So it'll be years since 1984. So then our next one here will be 50 when we do our 2034 prediction, and we want to know what that is, okay? So you could do this with these numbers here, but a lot of times in these math problems, they'll say, not use 1994 will be time as 0 when we started keeping records or something like that, okay? So let's bust out the calculator here and make sure that I can click it. All right. So there's a couple things we need to do, and I'll go through some of the errors that might occur as you're typing this stuff in. So first thing I'm going to do is hit stat, and we're going to edit. Okay, and I got L1, L2, L3, so on and so forth. If you don't have that in your calculator, for example, if this guy was just gone, see how that's deleted right there? Or now I don't even have L1 or L2. What in the heck? How do I get those back? Okay, so if you have L1, L2 and everything, you're fine, but I'd pay attention because at some point you may accidentally delete these things. You're going to hit stat, go down to setup editor, hit enter and enter, done. Now if we go back to stat, edit, all of them are back. Okay, so if you're ever missing a list, just go to stat, setup editor, hit enter twice, and then it will restore it for you. Okay, so if there's any data in here, like if I had some numbers in here, whatever it is, and I don't want these numbers, right, I can just go up to the top, highlight that L1, hit clear, enter, clears it all out. Okay, I would suggest clearing them out, not just typing over them, because if you type over them and there's extra stuff, then things go wrong. So just clear them out. Don't hit delete, because then you're going to delete the list. Hit clear, enter, we're good to go. All right? So now let's type this in. We got 0, 10, 20, 30, and 40. Arrow over to L2. I got 156, 466, 1142, 1838, and 4890. Okay. Wow, I really said those numbers in a very professional manner. 4,890. Okay, there we go. Wonderful. That's the stock price. So now, let's see here. We got, we want to calculate this regression model, right? So I'm going to hit stat again, okay, and arrow over to calc. Now, we're going to do a linear regression and we're going to do an exponential regression because that's what the question asks us to do. So let's go to linear regression, hit enter. I want it to pull from list 1 and list 2. I could store this regression equation if I'd like. Okay, maybe we'll come back and do that in a little bit if we need. And then I can go down and calculate. Okay, and all of this stuff should come up here, but unfortunately, I currently don't have some other stuff in here. Most importantly, my R value. Okay, that's what we're going to look at here. So why am I missing some stuff? You might have more stuff on yours. You might have what I have right now. Now, if you just have what I have right now, you're going to need to follow these steps. All right, we can hit mode and arrow down here to the stat diagnostics. And we're going to turn that on. Okay? So hit mode, go to stat diagnostics. We're going to turn that on. And now when I go to stat, calculate, do the linear regression steps again, Now I get all the good stuff. Okay, now I get all the good stuff. All right, so for our linear regression here, I will go ahead and jot it down in green. We're going to have, let's see here, y equals, I actually want to write it down below here, y equals, and then we have 108.4 x minus 469.6, and my r value is going to be 0.903. Okay. So if you're just getting introduced to this kind of stuff here, like if it's Algebra 1 or even Algebra 2, you're probably not talking too much about all the fancy statistics type stuff. You may just be asked to look at your R value here, your correlation coefficient. And the closer that is to 1, the more reliable, more dependable our model might be. Okay, so you want it to be as close to 1 as possible. 0.9 is honestly is pretty solid. There's other things that you also have to look at. Okay, this is not the only thing, but if we're just doing an introductory right now, which is really what this is, we're going to stick to just looking at that number. Okay, there's so much more with stats. It gets a lot more complicated, but we'll stick to the simple stuff right now. Okay, so now let's do the exponential regression. Steps are the same here. I'm going to hit stat, go to calc, but I got to go find exponential regression, which is like number 10. There it is. Okay, or 0, excuse me. So exponential regression right there. Hit enter. We got L1, L2. I don't have to type anything in again. It's just going to pull the same data. And we're going to calculate. Ooh, okay, so we have an R value of 0.993. Way better. All right, or much better, or I don't know, decently better. Stats people are weird, man. They're all like, well, it seems good, right? Do you feel good about it? I'm like, I think I feel good about it. All right, so our exponential is going to be y equals, and again, notice like the letters that they put in here, and they give you your coefficients, your base, and things like that. So A is going to be 180.676. I'll do 3 decimals, I guess. 676. And then our B value, our base, is 1.086. And then we'll raise it to the X or T, whatever it may be. All right, and my R value here is 0.993. Excellent. Very close to 1. And that's actually what we were kind of thinking when we looked at that graph, right? It had that curve to it, that growth look to it. I don't know if this way is the right way or that way is the right way when we look at the graph on the screen. I'm kind of reversed right now. Anywho, yeah, so it looks like our exponential model is going to be the better fit. We're going to base it off of that. We're going to say, hey, first off, the graph looks like it, right, when we look at this thing here. Second, my R value is much closer to 1 than the linear model. The linear model is probably not terrible, but that one definitely the winner. Okay. So here we go. Let's, instead of typing all these numbers in, I'm going to go back and show you guys how to store this regression equation, okay? First, I'm going to see what I have in my y equals. I'll clear that out. But now, what we'll do is we'll hit stat. We're going to calculate this thing again. So go back to exponential regression. Now, in this spot here, store regression equation. This is where I'm going to put y1. There's a couple ways to get to that, okay? There is the vars key. That's a vars right next to clear. Go to yvars. Function, choose y1, it plugs it in there. The other way of doing this is by hitting alpha trace, a shortcut for the yvars pops up. That was alpha, the green button, trace. Hit enter again, enter again. I get the same screen here, but if we pop over to the y, oh, it's all plugged in there. That's dope. Okay. So I could graph all this, but check this out. If I hit second quit, all right, I want to know the price in 2034, okay? So I essentially have, or not essentially, I have this equation stored in my calculator. You can actually do like function notation with this. Check this out. If I wanted to, I'm going to write it in function notation rather than how I have it here. We'll call it A of T equals 180.676. Then we got 1.086 raised to the T in this case. I could, see, for 2034 we said it was going to be 50, right? A of 50. Whoops. I can plug this all into my calculator without typing any of these numbers other than this little bit right here. Okay, I'll show you in just a sec. So we got 86, oops, to the 50. I can make that a 50. Boom, there we go. All right, so check it out. We're going to go back to the yvars or hit the alpha. For me, it's alpha trace. pulls up that Y1. If you need to, you can hit vars. I'll show you that again. Vars, arrow to Y vars, function, Y1. Cool. Parentheses, 50. It's going to plug 50 in to the equation that I have stored in my y equals. How incredibly convenient. Because there are a ton of decimals here. And if I use the rounded values, it's going to be slightly different. There we go. So we get, 11,247.72. Nice. 11,247.72. I wonder how different it would be if I use these rounded values. I'm curious. Let's check it out. You know, YOLO, you only round once. So let's see here how much the rounding would have affected it. Sometimes it does quite a bit, and other times not so much. All right, raised to the 50th power. Let's see here. The difference there. All right, so a bit of a difference, about $69 off of what the other one would have been. So kind of different, right? That's why I like to use the stored one. Storing the equation in there. I like doing that. It's awesome. I feel like this writing is on my face right now. That's okay, though. All right. Last thing I want to talk about here with this one, because I think it's very interesting. It's something that you might see on the internet and people talking about. This part right here. Okay, the 1.086. The way we get these things is usually 1 plus our rate, right? So in this case, the rate, 1 plus 0.086, we're saying that this right here is 8.6%. And they say the historical performance of the S&P 500 or your total stock market index or any of those things is generally between 8 to 10% over the life of this whole thing here. So if you take a long span of time, 30 plus, 40, 50 years, whatever it may be, your average growth is going to be between 8 and 10%. That's exactly what we got here with this information from the last 40 years. Okay, so that means if you're investing in the S&P 500, and for the long haul, not just for a day or whatever, because you see we got some dips in the graph and stuff like that. It can drop down, right? Those are unrealized losses. It goes way up. Those are unrealized gains. It's not real money yet unless you sell, right? But if you're in there for the long haul, your money will grow on average between 8 and 10% over that entire lifetime of that investment. And that's pretty dang dope, man. That's money is making money, and it's compounding annually. The money that just made money on that interest is now making that money on that interest on average. Okay. All right. So I'm not I'm not like a dude that gives, financial advice, but we are crunching numbers here, and it is checking out to what a lot of those guys say. So that's kind of interesting there. Anywho, I think we're about done with this one, but hopefully you guys enjoyed it. You see the value of maybe getting in early on something, long haul, smart investment, retirement, dollar bills. Don't say you never learned something in school that wasn't going to help you in real life. Invest early, hold it on there, be making them money, whatever. All right, I'm done. See ya.